Hey guys, welcome to episode 27 of Trading Signals, coding session series. Um, Today we're going to be working on debugging the arrival of signals into the second task server. So remember, we are upgrading trading signals once again after the second iteration of the peer-to-peer network. So, in the previous episode, we already sent the signals to the network, received the signal from the network, and we are there. We know that we need to implement um, the network service client. We know that, but even before that, I want to check out how was how were the signals being received before. Okay, so before, well, I don't have it anymore, but before we were accumulating the signals somewhere. I want to see where. I would have to find that module. For that, I will go here, trading signals, SA. No, this is signal validation. So task server, incoming candle signals. Okay, let me switch first to this view. Um, so WebSocket Network Client is where we get the signals message from the sockets directly, from the network socket. Then we should route it somewhere else. And that somewhere else is most likely this signal received. So let me check who is instantiating this guy. Remember, we had all this working before. The main problem is that we upgraded the peer-to-peer network and now it's not coming anymore. Okay, so the setup is being done here. Okay, so who is sending or using this? Well, it seems that nobody. Okay, so this is the initialization of the modules that are going to be dealing with incoming and outgoing signals. Okay, so we need to connect or reconnect because at some point this was being sent into those modules, but now the link is broken. Okay, so I have kind of all the pieces now. Um, what I will do first then is to create this network service client inside the peer-to-peer network client. Okay, so that is what is needed now. Okay, so for that I'm going to use the desktop app, a workspace here, close all the tabs that I will not be using now. I will need this guy, social network service client, peer-to-peer network interface. Not sure about this one. Or this one. And I will need this guy too on the other side. So this is network SA modules. So project network SA modules. Okay, so these go more or less like this. And I will not be debugging this, so you can go there. Okay, so let's check this out. WebSocket network client. No, this is not what I need. Peer-to-peer network client. This is what I need. I don't need you for now. Okay. So what's the story here? We have all these network modules and this social graph network service client. So we're going to add a similar guy that we're going to call trading signals. Network service client. Okay. Okay. The better explain things, the most people will understand. Um, in theory, we should also use this not only for receiving the signal but also for sending the signal. But let's take it easy. To send and receive trading signals to and from its counterpart in running inside a peer-to-peer network node. Okay? So what we will have here is this. Social trading. Okay, so with this we are going to initialize this. And most likely here we are going to send, instead of this connect to, we're going to send this peer-to-peer network start. That is similar to this, but it uses HTTP and it connects only to the start of the social graph. Okay. Sorry. So this is how we build this stuff. Then, since we have this there, let me check we are not having this from before. Okay, so since we have this, we will add another module here that is going to be similar to this, but instead of social graph, it's going to be trading signals. So initially we are going to use this as a template, and we'll replace this for this. And we will need a definition of the project schema. Okay, so far so good. This is like mechanic work. Okay, so this should instantiate this guy. So this model represents the client of of the trading signal network service running inside peer-to-peer network nodes. Okay, so here is where we will have some stuff to think about. Who is this guy first? Okay, the guy that we receive of node to connect and we will call it here. In this context, we will call it to be the trading signals network service proxy. Why? Because we are going to send a message through it to the network service running inside the network node. It is indeed a network module that is the one routing the messages through HTTP via blah blah blah. Okay, but for us, this is a trading signal network service proxy. Okay, then we have this peer-to-peer network interface. What is this? What is this and who is creating this? This module handles incoming message from the peer-to-peer network. There are no responses to requests sent. Okay. This is the case for any kind of event happening at entities follow social entity belonging to the user profile running this app. Okay. So what I'm seeing here is that first I'm not sure this is being used or I'm a little bit lost. So what I'm seeing here is that this social graph network client send the message. What does it do? No, it initialized this. And then what happens? Who is executing this? Who is executing this? Okay, so this is what the WebSocket network client is going to send a message to. Okay, why? Because the WebSocket network client receives the peer-to-peer network stuff, and then it can have a path to get where the message is going to be received. Okay, so this completes the circuit. This is the outgoing. Okay, this is the outgoing message. This is for incoming messages. Okay, so the network service client have a peer-to-peer network interface. Yeah, makes sense. Where it receives the messages. And in this case, the peer-to-peer network interface is this guy. So let's put the circuit here. This guy is going to call this guy. The WebSocket client is going to call this interface. And this interface in this case is going to check for the signatures and all this stuff and send the event to a callback function that receive as a parameter. Okay, so look, all this is all the wiring that is going on, which I think is okay. So to replicate this, so where is this guy, this interface, where is it getting this callback function? Okay, the callback function is coming together with the message received from the WebSocket interface, and is the callback function which we set in here where things are going to be sent. Okay, it's a little bit complex stuff, but it's the way to organize this in a way that makes sense. Otherwise it wouldn't make that much sense. But for our particular case, we will need that the task server sets the right callback function. Okay, and that is what we did the other day wrongly when we created peer-to-peer network setup. Remember when we did this peer-to-peer network? This is wrong. Okay, so the task server here, this peer-to-peer network interface, we need to delete this, and we are not going to have this at all. When we set up the network client, it's not this what we are going to send, but what you're going to send is incoming candle signals and probably the function name incoming candle signals, function name is signal received. Okay, so this is going to be the callback function that when a signal received, we are going to call it back with our signal. Okay, but before that, we will need all these other guys. So now we have a clear picture of how this is structured. Okay, so peer-to-peer network interface, then we will need this module that we don't have. We will need this module, but for trading signals. Okay, so trading signals client will come here. We already have the client, but we need this guy. So this guy is obviously a module of social trading. So we will copy this guy and make it a module of trading signals. So okay, so it's going to be called the same, but it's going to belong, instead of social trading, to trading signals. Okay, trading signals, and we will need this guy, signal validations. We will need a definition here, modules. Okay, so we have this is the peer-to-peer network interface of the trading signals client. Okay, so yeah, so we need to redo these two guys at the same time. Okay, and that is what we need for this to continue working as before. So this module handles incoming message from the peer-to-peer network that are not responses to request sent. Let's say that the incoming signals from the peer-to-peer network this is the case for any kind of okay, this holds true, although we haven't coded that yet. So we have a message received and we are going to replace this by signal received callback function. So we will check the message is in the correct format. We will the request type that is provided. I don't think that at signals we have a request type. So that's probably nothing. There's nothing to check there because there is no request type. So everything related to this is not actually needed. So even receive we will call it Signal receive. Hold on a second. Signal receive. Okay. I'm not sure that we have, well, we don't have these signatures. And I'm not sure that we have a signal message. So there will be a need. Okay, so okay, so this is signed by the social trading bot at the outgoing. The incoming, I don't think that we are validating this signature yet, but probably. Okay, so okay, here is where we run the validations. So what do we do here? Okay, so there are a lot of details on all this, but I really want to have this working like again so that people can start testing this and then come back and put all the details and all the validations. So how will I achieve that? My What I probably will do is to keep all this code somehow and just send this to whatever we were sending it before and leave all this code behind here, a return, so that it's not executed. Okay, and we can make all the validations in a future iteration. So I'm going to write a note here to do this point. I just this work. Okay, so this is the reality of today. I will put this to work by sending this as if everything works okay. And I will keep this code here so that when I come back, I can have a reference of what I'm doing at the social graph network service client at this interface when I receiving this stuff. But for now, I don't want to go as deeply as that, more deep than this. So I'm just going to call this callback function, and this is going to end up here at the incoming signal with the signal received signal. Okay. And from there we will see what happens. Okay, so this is how I'm going to deal with this now. Okay, so though this signal received even message is going to be signal message. Okay, so I'm going to do this, but here. So here this ends. So this is going to route me the signal message It's going to route the signal message into here, incoming signal, and from here we already have had this working. Okay, so I have a first implementation of this peer-to-peer network interface. Still work to do here. So let's check this out. Trading Signals Network Service Client. So again, we have this proxy that is for the outgoing signals. Then we have this peer-to-peer network interface. Yes. Send message. And how does this work? If we receive here a message, we will standardize this with this format, and we will require it to be a signal message or a request type that, by the way, I deleted these validations of request type. I will add it so that I keep this standardized as much as possible. Request type. Okay. So the request type must be signal. And what I have here as a query message or probably I will use the even message as a signal. Even message is going to be signal message. And then we will not have this profile. Okay. So from everything that this guy does here, the only thing that we need to do okay, so we were already signing this, but not here, at the outgoing trading signals, or so again, I want this to work now. Okay, so this we don't need. Some validations. Okay, so I'm going to keep this. I don't know how far this will take me, but to keep things in a standard way, I need to do it in a similar way, even if I have to redo some stuff. So this is how the message is sent through this service. Okay. And the final point that I need to change is at the peer-to-peer network WebSocket network client. At this guy, we will finally add what is missing here. So this is going to be trading signals, trading signals, trading signal network service client. Okay, and we are passing the callback function. So here, social graph is going to be trading signals. Okay, so all the code has been written now. I will need this. I will need this at my task server too. Okay, WebSocket network client. Okay, first at task server 1. Okay, there is something that we haven't changed, and is that so there is one guy here. This should go, instead of peer-to-peer network start. Okay, let's clean a little bit this stuff. We don't need this guy, we don't need the start. Trading simulation maybe, outgoing. Trading signals, no. Candle signals, yes. Incoming node, peer-to-peer network client, yes. And this guy has the social. This is incorrect. Dios mío. This was incorrect. That means that this is incorrect. This is incorrect. My God, how can I do it so wrong? This is all incorrect now. Trading signal network service client, yes. Trading signal network service client. Where is the conflict? Okay, now I'm confused. I don't know where we are standing. It was a stupid mistake. Okay, so to clean this up, to clean this mess, what we are going to do is to run task server 1, network service client, and we will debug this from here. Okay, let's go. Let's do this. Social trading. Oh my god. So this is social trading. Of course, this is not going to be here because this should be the trading signals project. Okay, so we have UI, NT, TS. So let's try this again. So if you cannot find it, it's because why did they do this so bad? Unbelievable. What I was thinking about. Okay, again. Okay, the modules are loading. So we will go to the UI, which I don't know where it is. It's not here. Okay, here is the UI. So we will connect this with this guy debug. Okay. Okay. It's not going to be a good day today. Let's go again. Okay. So the initialize of this guy is going to the proxy is going to be the start. Hold on. Hold on. Why do I need to do this? A bootstrapping process. Okay, so the bootstrapping process is not something that we need to run because there is no bootstrapping process for signals as far as I know. Then this is also not going to work because the peer-to-peer network interface in our case is going to be this guy. Okay, so then when we are actually going to send the signals, we'll put a breakpoint there. But we are going to on the peer-to-peer network client, we're going to use this guy to send the message, or this message, that this guy is waiting for here. And I don't really know why this is trading signals, because the network start was requiring this. If you see the, thank you. If you see the network start, it will require a network service. But this is going to be probably inside the message. Okay, so what is important for us is that this is going to the new stuff, and from there we will see how we need to set this up. Okay, so we have a breakpoint here, and we are initializing this guy. We'll put a breakpoint here, and let's run it. Okay, so this is working. This means that this is working. That means that we can let it run. Okay. Now we need to execute all this. We need to execute the signals so as to debug what happens when it tries to send it with all the changes that we did. Okay. So now we have a signal message with a signature signed by social trading bot 1. Okay, so this is going to go into our trading signals network service client for the first time. We get here, and this is going to fail because we had no request type. Okay, so the request type does not exist, so it's going to respond with this. Request type not supported, and God knows what is going to happen there. So as we try to standardize this, so it seems that we need here a message header, okay? Not just a signal like this guy is sending, okay? So that's what we're going to do. Say let message header equals to request type is going to be signal, and this guy from inside signal message JSON stringify signal message, and this is not going to be a signal but a signal message, okay, because the signals are something else. Okay, what else this guy is going to need? Signal message, so this the social persona ID So maybe we can add to the signal message who is the bot. So let's simplify a little bit this stuff. And let's do the social trading bot. We're going to use your code name like this. And it seems that this signal message need a origin social trading bot ID. Okay, so that's what we're going to do. And now we have it. Okay, so because we have it, we don't need to simulate this. Okay, so this is gone. We need the origin social entity so as to be able to sign this event or this signal. So if we have the social bot ID, okay, so it looks like the signature we are putting a signature on the we are putting on the signal, but that is something that is probably not needed here. And also the social trading bot origin social trading bot ID. Most likely this is not needed either. Okay, I'm going to undo this and standardize it. So we don't need this guy. Okay, wait, hold on. So I'm going to put a break commit here. So Then I'm going to need I'm going to need this signature will not be needed. This message header is what we're going to send, and this web3 is not going to be needed here, which by the way looks better without the sign in here, because it looks better for me. Okay, so then the idea is that this is going to be signed here, and it's going to be passed into this guy that I don't really understand why this guy I don't really understand why this guy need the network service. Because this guy adds. So the one who needs to add so we are not going to receive the network service here, but we are going to add this to the message header directly at the network service. So when we receive this, well, in the case of the other guys, when we do a social graph, the network service was coming inside the message. So to keep consistency, we're going to say here that the network service is going to be trading signals. and the signal message is this. Okay, so now it looks better. Okay, so let's debug this again. Okay, they started. Okay, so the message header is going to be trading signals, signal, and the signal message. No signature in here, but the signal message will contain the origin social trading bot ID. So this have this. We can parse the signal message. Okay, so the next problem we have is that we cannot have a social entity if we only have social personas by ID. We should have a map of social trading bots by ID. So that means that this is incorrect. And that means that the similar stuff at social trading this was incorrect. Okay, so let's go back again and run this again. So we debug this from here. Run here and wait. So we can remove that breakpoint, get in here, social entity is not undefined, we have a social trading bot. So all good. So if there is no timestamp, we are going to create one. Then we stringify that stuff again. And then we're going to sign the message at the message header. Okay. And then we're going to send this, but we don't need to do these trading signals anymore. So now we have the message only. The problem is that this is going to override the message, the signature of the bot by the signature of the application. Okay, and that means that there is an inconsistency on how we are dealing with this. Or maybe there is no need to sign with the application because we already signed with the bot, and with the application we already signed it in order to establish the connection. But the problem that here there is no connection. So it looks like we need to have oh, wait, hold on. We are creating a new header here, so it might work because this is the header of the transport layer. So we have a user app and the message is in stringify in there. So this might work. So here we have the user app with a payload, and this is the transport layer that has a payload and a signature. Okay, so what is not correct is that we are signing a node ID, and the signature of a node ID is always the same. So that is not a good idea. We need to sign something else. That is the reason why we are signing here the inner message. So we either sign the inner message, the payload, with everything it has, which by the way makes sense because that is, if we want to control the hash, then if we want to control the hash and that the payload was not changed, then we should sign the payload. Okay, so there is a small problem with what we are signing here. And I know that signing the payload is going to duplicate the whole message of the payload as the message of the signature. But I prefer that and being highly secure than less information, not so secure. So we're going to do like this. Let payload equals to the message stringify. Let's put this in here and let's sign the payload. That's the way to do it. And then we send this stuff. Okay. So then this is going to enter into the network. Is going to enter into the network. So we have the WebSocket interface and we have the HTTP interface of the network. So we will stand here and see what happens. Okay, but we're going to run this again patiently. Okay, so this is working. This is working. And this is getting in here. We have the payload, the signature of the payload, and the message header is going to contain the payload plus the signature of the whole payload. So this is going to be awesome. Now we can let this go and send it to the network. Not so fast. Mm. So it seems that we need the message header also inside here. So, sorry, the network service. So we will take it from the payload network service. How is this possible? Okay, it's not the payload. My God, it's the message. So we will need, sorry, but here there is a confusion. Why am I sending this stringified stuff? I need this to be not stringified. Oh my God, again, this is message network service. Now it should work. Okay, so now this should send a signal and I receive it here. Okay, I'm not going to send the other one, but let's check this out. Okay, so this message, in fact, what I receive here is not the message, but it's the payload. Okay, of the transport layer. So once I have this, what I actually have is a message header. Okay. So this client interface is similar because this is the client interface of trading signals, but there is a client interface. There is a client interface at social trading. So look at the differences here. Trading signal modules, client interface, social trading module, client interface. So it's clear that what this guy received was a message header. So when we convert it, and we don't have to parse it, because uh, at our WebSockets interface, when we send this in, it's already parsed. The payload that we are sending has already been parsed here. So I like that. So I'm going to copy this in here too. Okay. So the important thing is that we have our payload here and verify there. So here we are sending the payload. The HTTP interface doesn't receive the caller user profile. In fact, this doesn't even exist. Just the payload. Okay, and that means that this parsing that happens here is not needed. We won't need it, and we will pass it in there. So what happens at the client interface of social trading? We are checking this stuff. So this means that here we are going to do something similar. we receive this message header, we want to check here that we have a request type. The request type is only possible to be signal. So here we have a function for this called event receive with the event message. Um, Probably after the signal validation, we do similar stuff that is going to be um, signal received. I'm going to send a signal message. Okay, so let's go until here and debug all this part. Okay, I want to know if this part is okay. So we're going to debug from here. By running this again. Sorry, but it's not this way. Running this again. So let's stop this and start again. So we debug this here. And we run it from here. Okay. So we are here. Socket message is not defined. Here we go again. That means that we go again here too. That means that we need to run this again. Okay, we don't have this and it's going to explode. Okay, so up to here we can say this is working. But first we're going to run more validations of the signatures in here. So, and once we are here, If I send you, why do I send you the signal message? Why don't I send you directly the message header? In the same way that I used to have it. I'm not going to consume inside the node the signal. So I just pass the message header and whatever I have here is what I will broadcast. Make sense? So let's see if we can take this. Um, okay, I want to make sure this is working and see what happens from here. Okay, so again, we run the network, we run this guy, debug, debug, and run. We run this. So this part is good. And we're going to validate signatures. Okay, so we go in here. I don't think this is a signal we're sending. The signal message is inside, but let's see. Okay, so there is a misunderstanding here because this signature that we are validating is not the signature of a social trading bot. Okay, although this is going to work. Okay, so the problem here is that what we receive here from here is the message header. Okay, so signal validations is receiving a message header that from there it has to extract the signal message. Okay, so hold on. Signal message is going to be more or less like this. Okay, so now that we have a signal message, then we can do this. Okay, so we will debug from here, run this again, and run this again. So we debug, and while this is running, this guy or this guy, we run this. We run there. We're going to validate the signatures, and for that we parse this guy. So it was not working that way. So what do we have here? We have we had what we needed to have. The message header, and this signature is already the signature from the bot that is signing everything that is inside. is signing the signal message. So I don't need to do this. Okay, let's try it again like this. So this was incorrect. So sign message is equal to message header signal message. Okay, that's the signed message. This is message signature message. Okay, then the hash. We're going to hash the signed message and compare it to the message header signature message hash. Okay, this should do the trick. Okay, so now it should work. So here we go. And we get into here. So signal message is what we sign. And okay, so I didn't need to stringify this because it's already stringified. And stringifying it again produce a problem. So let's do it again. Let's stop this and run it again. My God. Now I have this task where I need to stop it. Okay, I'm getting a little bit tired and making a lot of mistakes. I need to debug. Once this is ready, probably it's not a bad idea to run it outside the IDE. Okay, so these signatures have been 100% validated. So this means that this problem is gone. Now the request type is this, so I'm going to send a message header in here. Okay, first problem is that I sent it a wrong parameter. So here, okay, I still have the message header. So this is probably going to work. Let's check it out. So socket message. Okay, no, it's not going to work because this is a socket message what it's expecting. And I don't have the socket message here. I got the request message. For this to be a socket message, I need to add the things that the socket message have, but probably I need to add it here. Uh, Sorry, we are talking about the WebSockets interface. So here we need a socket message. And broadcast to clients, create the socket message. And essentially the socket message is exactly the same message that we received. So how do I get here exactly the same message that we receive? And I get it by responding here. That's how we get it here also. WebSocket interface. The problem is that I cannot respond into the WebSocket interface because I simply can't. So I need to produce the socket message in here, which probably I will. Maybe I should get the socket message header and socket message. So here I could send in the payload and the socket message. So if we need to broadcast, then we broadcast the untouched socket message. Okay, whatever. So this is the way it should work. Okay, so let's finish this. Debug. Let's stop this and run it again. Let's come here and hit debug. Debug. It's very annoying. Okay, I will just run this task from here. But it wouldn't stop this. Oh my god. What about lag? Okay, let's run the task. Should be faster here. Okay, so we run this. That was faster. So signals received, where are we? We got the socket message. Okay, the caller role will need to be replaced, but the rest is okay. Okay, so let's check this out. There should be at least one. Okay, so the network side is done. Okay, the network side is done. Okay, so this is getting a little bit long, almost 3 hours. So we're going to continue the debugging process after a break at the next episode. Okay, so to summarize, we have rebuilt. Okay, I'm going to just commit this debugging signal sent from server 1 to peer-to-peer network. Done. Okay, so essentially we have been able to move the signal through the new infrastructure from task server 1 through the peer-to-peer network, and now we need to receive it at the other end. And we will continue debugging from there at the next session. Okay, so thanks for watching this one, and see you in the next one. Bye.